excise tax definition. This is a tax put on a producer. So you make a good, I'm going to tax you to make it. So obviously the government's trying to scale back the production, or they're just trying to make money. What happens to the supply curve when the excise tax? Well, look at the graph. Supply moves to the left. Okay, supply goes down because it's more expensive to make, so less producers are willing to take on that cost. Number 3, how do excise taxes affect efficiency? Look at this graph. You went from the Q1 to Q2. Well, that triangle, that red triangle there, is what is lost. So that's called deadweight loss. So it's inefficient. So you're supposed to draw this, number 4, draw it on the graph. Hit pause and draw this on the graph. You do want to mark these specific elements here. The red, color that in, that's the deadweight loss. You want to label the tax revenue. The distance between, you pick a point on the supply curve, the original. Go up in a straight line up to the new supply curve. That is the tax. You can do it at the blue line where I did it, or take your pen and move anywhere on the original line. Now, put your pen on any point on the original supply and just go up a straight line. Anytime you do that, anywhere on the supply curve, that'll be, let's say the tax is $2. Everywhere that vertical line will be $2. That is the distance for the tax. So you look at the tax revenue, that blue code, it's $2, $2 tax from P2 to P301. That's the $2 tax. Now, times let's say the government gets that $2 tax on every quantity unit of good that's produced. So your price, $2 tax, times your quantity, 0 to Q2, that whole rectangle is the tax revenue, which is what the government gets. Now, how much does a producer and how much does a consumer buy? Well, first what you do to figure that out is you shade in the tax revenue. That's the gray area. Then you start at the top and you go down to write this rule down. You go to the tax revenue, down to the old equilibrium line, and that is the portion that the consumers pay. Then you start at the bottom of the rectangle and you go up to the old equilibrium. That is the producer. So in this graph, looks like the consumers pay just a tad more. The graph might actually be trying to show that they pay it evenly. But so you start at the top of tax revenue, down to the old equilibrium, consumers pay. Bottom up to the old equilibrium, that's what the producers pay. Okay, the next bullet point question asks, how much of the tax do producers pay when demand is perfectly inelastic? That would be the top graph. Demand is perfectly inelastic means it's vertical. Means no matter what the price is, the quantity demanded is the same. An example would be insulin. Doesn't matter what the price, you always need it. So an excise tax in that case is going to go purely on the consumer. So if you look at the tax revenue, that entire portion is paid by the consumer. It makes sense, if a government wants to get tax revenue, it's good to do on a good that's perfectly inelastic in its demand, because people are going to buy it even if there is a tax. Looking at the second graph, so the next bullet point, if producers are going to pay the whole tax if it's perfectly elastic. So you look at the tax revenue box and you go to the supply curve up to the old equilibrium. Everything is paid by the supplier. So just make sure you know, perfectly inelastic, consumers pay it all. Perfectly elastic, producers pay it all. So number 5, to maximize revenue, the government taxes goods. Which price elasticity? Inelastic. The more inelastic the demand is, the more the consumer pays, which makes sense. The last segment here on taxes are subsidy versus per unit taxes. Treasure hunt question tonight. Brian's nephew turned 3. So come and tell me that Devin, his nephew, turned 3. Okay, so what happens with subsidies? Well, with a subsidy, that means the government gives money to producers, so supply is going to increase or shift to the right. Well, what's the difference between lump sum and per unit taxes and subsidies? Lump sum, you get it. If it's a tax, you get taxed the same amount whether you make 10 bananas. Here I say 1 banana or 100. Doesn't matter. You're going to pay an extra $5 just for being a banana producer. Per unit, you pay an additional tax with each additional banana. So 1 banana, I pay $5. 100 bananas, I would pay 5 times that. So the more bananas you make, the more tax you actually pay. What you want to write down, lump sum taxes or subsidies shift just the ATC curve. So if you drew, I would jot this on the side, your X and Y axis, and you draw the marginal revenue cost, that little check symbol like a Nike swoosh, the ATC, and let's say pure competition, the straight across MR curve. So draw those 3 curves. The ATC will change in a lump sum tax. If it's a tax, the ATC is going to shift up, right? Your costs went up. But your price and quantity don't change because MR equals MC is where you get your quantity and MR is the price. Neither MR or MC have switched or changed. So the only thing that changes in lump sum are going to be your profits, either going up or down. Per unit taxes change your price or quantity. In perfect competition, it's not going to change your price because MR is always the same. But MR equals MC for your quantity, well, per unit taxes or subsidies do shift the MC curve. So that's really important to know. In lump sum, only ATC moves. But in per unit, the MC moves as well. Give you a space if you wanted to graph it. The lump sum subsidy, again, you want to draw your MC curve first, then your ATC, and then you can put an MR at equilibrium. If the lump sum let's say subsidy happened, your ATC would shift down. For the per unit subsidy, MC would shift down along with it. If it were taxes, obviously on this slide, the ATC is going to move up because costs go up. Okay, the Lorenz curve. Draw this. You don't need to draw the whole box, just the X and Y axes, and do label them percentage of households and percentage of income. Then draw the AB line. That is your reference line. That means if anywhere on that line would be perfect equality. So any point in that line, X and Y are equal. So 1, 1, 5, 5, 100, 100, meaning 5% of the people hold 5% of the income. So line AB is perfect equality. What this curve measures, and you should write this out, is the income distribution in a nation. Write that. Income distribution in a nation. The blue curve, the space in between it, it's called the bulge, but the curve shows how wealth is distributed in a nation. The bigger the bulge, the more unequal income is distributed. So the closer you can get to line AB, the more sort of fair or equitable your society is. Okay, the last thing that we have on here then is your government regulation of business. Write these quick definitions. Antitrust laws, those are laws to promote competition. A trust works like a monopoly, and if you're anti-monopoly, you're trying to make sure that multiple companies can compete. So the point of antitrust laws are to promote competition. Sometimes this can cause inefficiency when the government controls it. B, deregulation. That is when the government does not control it, or they control it less. Regularly or typically, deregulation equals, write this down, greater efficiency. The idea is when the government tries to regulate it, oftentimes there's a loss in efficiency. So if you see that in the AP test, deregulation is going to be about being more efficient, and antitrust laws are going to be about promoting competition. Go ahead and do the practice questions. They're super important, especially the one on taxes. Come in with any questions that